Hello, welcome to my channel, The X. Have you ever wondered what happens when a jet breaks the sound barrier? Let's start by taking a trip back in time to an era when breaking the sound barrier was considered impossible, a daring dream of aviators and scientists alike. Today, this once elusive feat is a common occurrence in the world of aviation, marking a significant milestone in our journey of flight. But what is the sound barrier, you might ask? Think of it as an invisible wall of sound waves, a boundary that exists at the speed of sound. As an aircraft accelerates, it compresses these waves, creating resistance. This is the sound barrier. Now imagine a jet racing through the sky, faster, until it hits this barrier. The tremendous energy required to break through it is what makes this feat so remarkable. What happens when a jet breaks this barrier? You ask. Let's delve into the science behind it. When a jet breaks the sound barrier, it's not just a matter of speed. Indeed, it's a symphony of physics involving sound waves, speed, and shock waves. Let's delve into these concepts to understand this phenomenon better. Sound travels in waves, similar to the ripples you see when you throw a pebble into a pond. This is a result of vibrating particles in the air which push and pull on each other, carrying the sound from its source to your ears. Normally, these waves move at a particular speed known as the speed of sound, which is roughly 768 miles per hour at sea level. Now, imagine a jet moving slower than the speed of sound. The sound waves it creates can propagate in all directions, including forward. But what happens when our jet decides to pick up the pace and outstrip the speed of sound? Well, it starts to catch up with its own sound waves, compressing them together. As the jet surpasses the speed of sound, it effectively outruns its own sound waves, leaving them behind. This compression of sound waves creates a phenomenon known as a shock wave. Shock waves are intense pressure disturbances that move through the air at supersonic speeds. They are quite different from regular sound waves. While sound waves smoothly move air particles back and forth, shock waves violently push air particles out of their path, creating a wave of high pressure that propagates outward in a conical shape. As a result, a sudden change in pressure occurs, which we perceive as a loud bang, often referred to as a sonic boom. But that's not all. These shock waves also interact with moisture in the air, causing it to condense and form a visible cloud, which we often see as a ring around the aircraft. And this leads to one of the most captivating phenomena in aviation, the formation of a ring of air. So why does a jet create a ring of air when it breaks the sound barrier? Well, it's all about changes in air pressure and temperature. As a jet nears the speed of sound, it compresses the air in front of it, creating a pressure wave. This is the sonic boom we hear. But what about the visible ring of air, or more technically, the vapor cone? This phenomenon occurs due to a sudden drop in air pressure around the aircraft. When the pressure drops, so does the temperature, and this causes the water vapor present in the air to condense. It's like when you open a bottle of soda. The sudden decrease in pressure allows the carbon dioxide to form bubbles. In the case of the jet, the drop in pressure forms a cloud of condensed water vapor, creating that spectacular ring of air. So, it's not just a cool visual, it's a demonstration of physics in action. This is the same principle that leads to the formation of clouds in the sky. Breaking the sound barrier is not just about speed, it's about science. As we've discovered today, this fascinating phenomenon is a symphony of physics, aerodynamics, and atmospheric conditions. First, we explored the concept of the sound barrier, a sonic threshold that, when surpassed, results in a sonic boom. This boom is the audible manifestation of a plane moving faster than the speed of sound. Then, we delved into the science behind it all. We learned about shock waves, those intense pressure waves that form around the aircraft as it pushes against the air ahead of it. These waves are what cause the thunderous boom we hear when a jet breaks the sound barrier. Finally, We've seen how these factors come together to create an impressive ring of air. This ring is actually a visible shockwave, a testament to the aircraft's power and speed. Next time you see a ring of air around a jet, you'll know it's not just a spectacle. It's science at its best. Thanks for watching. Subscribe for more interesting videos like this. Have a nice day.